Now you can tidy up the graph by adding frames to the node groups. So this part is the speakers, and we made this part for the grids for voice came out for the speakers. Still, we are having some problems on the grid area around the speaker part because the punctures on the front surface is looking weird on the edges. So we need to realign the seams of the speaker part, including the grids that we made with the points. Also, there are some crispy edges at the seam. It is caused by the unblurred, sharp, dark rectangle there. So even if we increase the tessellation factor to increase the polygon count, it will be problematic. So you can see that when I increase the tessellation factor, the seams are looking smoother, but this time our viewport is very slow because it takes too much system sources. To get rid of this problem, we need to add a blue HQ grayscale for this seam to smooth out the edges of this shape. This one works nice on creating the smoothed edge, but we need to find the outer boundary of this seam to smooth out with the blue HQ grayscale. So this is the shape that we are going to smooth out for the outer boundary of the speaker shield to smooth out on the seams. So I added a blue HQ grayscale, increasing the intensity with minimal values to smooth out the outer boundary of the seams. Now it's look better than the previous one, but our seam uh, got widened because of the smoothing process. So we need to adjust some of the edge detect nodes to create the better seam on the speaker. Now it's looking better. Let's adjust the blur intensity once more and check the seams of the speaker. Now we can work more on the general frame of this monitor or screen. And also we need to make a connection between the speakers and the general frame by some uh, placements between this frame and the speakers to make them look like whole at the end. I will add a transformation 2D node to place the speakers a little bit to the up to connect with the general frame of this monitor. Now we need to add an additional frame for the speakers to connect with the general frame of the rest of the screen. I'm adding a shape for this task, scaling it a little bit down. Now I will add a blend node and add another transformation 2D node for the shape itself to subtract the transformed shape from itself to generate a frame for this rectangle. Now I'm decreasing the height and width of this shape by this transformation 2D node, and I will change the blending mode of this blend node to subtract. So by this way it will be just a white frame in a black canvas. To crop this frame, I will add a shape, and for this shape I will just change the transformation of this, change the position of this shape to subtract it from the previous frame. After the defining the blend node, I will use the transformation 2D node to move up the white shape to subtract it from the general frame. This way we will get a U shape, and this U shape will be the cover for this bottom speaker area to connect with the general frame of this screen. I'm setting the blend mode as max, so both white values will be considered as the maximum result at the final combination. First, we need to adjust the scale of this U shape to comply with the rest of the frame. I will add a transformation 2D node to reposition the U shape vertically. Now it's time to adjust the width of this U shape. We put the positioning transformation 2D node after the shape, so I will remove one of the transformation 2D nodes and leave the one that creates the frame width of the subtraction between the exact shape. So I will add the transformation 2D node afterwards to move up vertically the U shape, so our design will be better this way. we are still having the width problem of the additional U shape. So I will change the scale of the transformation 2D node to make a thinner U frame by changing the width and height transformation at the transformation 2D node. You know the values you enter to the width and height of the transformation 2D nodes as a value are relatively taken into count because if you keep adding if you keep entering a value like 110, it will continues to scale up the shape by 10% every each time you enter every each time you press the enter button. So they will be taken into account by relatively. I'm making the better placement by moving the subtracted shape vertically to make sure that I get the perfect match with the blending of these two uh, frames, like the U shape and the previous general frame of the monitor. So after that, I'm adding a Blu-ray HQ grayscale to make a smooth blending of this U shape. Now you see that we have some thickness difference again, but the general positioning and scale is looking good by this way. So making continuity between these two frames, I'm adding a blend node, and after that I'm adding a gradient node. So I will control this gradient node with a curve to create a profile uh, of these two shapes. So I'm increasing the tile of this gradient node with a transformation 2D node because we have a narrowed area of this U shape for to be considered as a gradient. Uh, so we control this area with a this narrow area with a gradient. So I will turn off the tiling of this gradient node, and at this narrow point with a gradient, I will control the profile with the curve node after making a connection between the previous U shape and this gradient with a blend node. So after inversing the gradient, I will now adjust the points of this curve node to create a profile of this gradient to be act like the angles of this frame. So I change the points to a non-Bezier straight corners. So I will adjust the white levels of this corners or points to create the shape of my secondary U frame. I'm changing the curves points to match my U frame of the speakers to make them comply with the screen's existing frame. Now we have a seam between the existing frame and our speaker frame, but it looks not bad at the end, so I will leave it that way. General look is looking good, so I'm adding a frame to define this node set. Since our speaker grid dots are at the end of the blending, height map blendings, and they are independent from the height map because we are using this detail not geometrically because they are too tiny on the speaker grids. They are too tiny, so we use them as normal maps and ambient occlusion detail. So they are at the last part, and we rename that and we add the frame for them as well. Now we can create the color detail by masking every component on this screen. So we will be using the previous nodes to create black and white masks out of them. So we will use these masks to define individual colors for each part, like the frame, outer frame, inner frame, and something like that. So I will be adding uniform color of each part individually, and then I will use a blend node and use these masks that we are going to create to blend these different colors with blend nodes. So let's define the colors first. I will use some old style colors like brownish yellow, some light black, and for the speakers, let's use total black at the end. So I will add the frames for each color for me to remember which color I defined for each component on the screen. There will be a constant color for the screen when it's turned off, like a greenish gray. So it's the color of the glass of the CRT screen. Since the colors are now ready, I will extract mask of the each part by the height, by the nodes that we have created the height map of this components. So I will blend each color with the final blending by using an opacity mask extracted from the previous part. So for the inner frame, I'm checking the nodes which I created the inner frame. So as you see, these results are having transitions, color transitions or grayscale transitions to create height maps. So we will just squeeze the color values of these nodes to end up with a straight black and white mask. Since there is a mask for this part is already defined previously, we can use this as a mask to see how it looks. So I'm connecting the final blending of the colors to the base color output and checking to see that this mask covered the inner frame perfectly. So it's looking okay. I'm adding another blend node and connecting the third color, which is the speaker frame, to that blend node. I will always use the copy mode for these blendings. So the upper color will override the bottom layer with the correspondent opacity mask that connected to that blend node. So now I am looking for the perfect mask for the speaker part. This looks good, but we have a color transition there. We need to find the previous state of this gradient blend. So this looks better. And I'm connecting this to the second blend node to define the speaker frame color to override the previous color blending. So when I change the color, it's more recognizable that the mask that we are used is a prior state that we moved up vertically the speaker node. So we need to move this mask to the vertically to the up with the same amount that we used previously on the speaker height map. So I will copy and paste the transformation 2D node that I used to move up the position of the speakers and connect it to the mask that we used for the color blending. So after doing that, you can see that the top position has been matched with my speakers, but still we are having some level error or boundary error with that mask. So we need to adjust or find a better mask for the speaker. Our speaker mask also reaches or outbounds to the speaker frame as well, and also the levels of this mask should be adjusted because the height map extrusion on our object has created a look which looks bad at the seams. So let's subtract the speaker frame from the speaker mask first, but we need to adjust the levels of this mask as well, or find an untouched black and white mask to subtract it from. So I'm connecting the better frame mask. So this makes the isolation of our speaker with the speakers with that mask. So I'm subtracting the unblurred version to get a sharper result at the speaker mask, which is good right now. So my next step will be extending this mask a little bit to make the seams work better with different color, by defining the different color by this mask. So we will extend this area to match this height map inaccuracy for this mask. To do that, I will add a Blur HQ grayscale node and blur the shape, but you can see that blurring creates a gray values uh, outside of your mask. So we need to use a levels node to compress the values to a total white. Be careful while squeezing the color handles like this. I don't suggest you to push all the handles uh, over each of themselves because it creates a crispy result at the end. But changing the blur amount like this, you can see that we have found the perfect mesh, but pushing all the handles to the 0 made the crispy leveling for that mask. So we will adjust the handles a little bit loose to get a more smooth result at the end, like this. Now we can revert back to our original color that we want to be at our speaker, on our speaker objects. For the speaker grills, we will use a different color to blend with the rest of the color blendings. So I will add another blend node and look for a mask for the speaker grills to be used as a blending opacity input. So I'm connecting the top layer of the speaker grills. It overrides all the colors that we have made so far. So adjusting the inner side of the speakers, adjusting it with finding an inner side of the speakers as a mask will solve our problem. So let's use this node to be as a mask. I will change the color to see if it worked good or not. So this looks great and works as a mask that we need. But you can see that even we defined a white color for this speaker grid, we end up with black dots on our grid. It is caused by the ambient occlusion channel, because as you see on the base color channel, we have a total white, but our result is with black dots. It is caused by the high depth of this ambient occlusion channel. So I will decrease the height depth a little bit to make my color more visible even in the black parts of this speaker grills. I added another blend node for the screen, so I connected the screen color. Now I'm checking for the glass part of the screen to see if I can get a mask for the existing nodes. So we need to find a rectangular shape with rounded corners without the which doesn't contain the outer frames on the screen. And also for the blending of the screen and the frames, it is better it may be better to use an height blend to get a perfect seams between these two height levels. Sometimes it generates the same result with max blending with the blend node, but let's check if it works better with the height blend, because when you blend two height maps, you get a height mask between these two height values. So the frame and the screen, after blending the frame and the screen, height blend node gives us an height mask. So we can use this mask as a screen mask to be used as the glass to define the color of the glass part. I'm adjusting the height blend offset to see if I can get the same result with the classic blend node which I used before. But this time I won't be uh, needing to create a screen mask by myself. So the height blend node will give me that mask. So I'm connecting the mask that we extracted from the height blend node to work as the screen mask. Let's see if it looks good when we change the color of the screen to see the contrast. I don't want to lose the previous color which I have. So we need to invert the mask, by the way. Looks good. And you can see that we have a great uh, mask that defines the screen glass with the height blend node that gave us the mask of the object. Still, we are having troubles with the height map of the corners of the frame. I will check to see if I can make a better roundness at this area because it looks crispy and looking out of the way. So let's check it. This part looks very sharp after the blending, so maybe we can adjust this uh, white level of this area by changing the curve node to smooth out that sharpness. It didn't work good, so I'm checking to see where I can correct this crispness at the corner. So maybe blurring this node will give us a smoother corners at the end. Works better, but still there is a sharp perpendicular height map definition there. Now it looks better than the previous one. So let's say just change the sharpness of this corner to see if we can get better transition there. It's looking better just right now. Grouping these color blendings with a frame to tidy up my graph. So these nodes are used for extracting the screen mask. this time I will create some other constant values with this time I will use grayscale colors to define the roughness values on of the object. So as you can see, for our object, we will be needing low roughness for the glass part and some various roughness values for the other plastic and metallic parts of the screen. So the inner frame, we can add a difference with the inner frame with the outer frame by making a roughness variation between those, and the glass part also needs to be shiny with low roughness, and the speaker parts will have maybe a little bit more rough, but they will also need some metallic values at the end to make it look better for our object. So I'm adding different grayscale values to define different roughness values. Let's add a blend node and blend them with specific masks. Most of them we have already defined for the color blendings. We defined the lower roughness value for the specific parts like the speaker grids there. So for the speaker frame, I will use the previous mask to blend it. One blending is unnecessary, so I delete it. Now checking the general look to see how my roughness working. Looks good for now. We will adjust it later on. Now we can add the frames for each roughness value that corresponds to the related area that we control the roughness of. Now we can adjust the independent roughness values to create a better look on the final plastics and glass parts of the object. We have some reverse renaming with the speaker frame, between the speaker frame and the grill. So I will change the order of this blendings and correct the masks that should be used for these areas. So after changing the order of the nodes and the frames of the two masks, we are finally done with the speaker frame and the grill confusion. We have some flatness on the glass part, so let's check that part and make a more bumpy CRT screen at the end. Let's try to control the curviness of the glass with a curve node instead of level, because we need a lower white values for this glass part when it gets nearer to the frame. So the white value should be more intense on the center of the screen. So let's control this bumpiness by changing a bezier point on the object. For the seams of the CRT screen, we should have a direct angle from the edges of the CRT to get under the frame of this screen. To do that, we need to have an edge form, then we will have to blur it and then subtract it from the general bumpy shape of the CRT. In order to do that, I will just push down all the white values first to create a mask of this screen shape. I can also use the one we have extracted from this blending, but I don't want any blending data right now because pushing down the values on this CRT in earlier stage is much more valuable right now. Now I add an edge detect node and increase it a little bit without any roundness. And also I will click to the invert option to get the right color for the edge mask. Then I will use a blur HQ grayscale node to smooth the result. Now I will add a blend node and subtract the blurred edge from the general shape. You can see that now our screen is bended from the edges to get a greater, much better look as a screen blending with the frame. Let's make it better, by the way, because we may have a different color distribution on the inner frame, because the subtraction is too intense. So we have a gap between the inner frame and the screen this time. So we can adjust it by decreasing the edge detect node's edge width value, and also we can adjust the subtraction of this blurred edges of the screen shape. Let's start with increasing the edge width, and then I will decrease the subtraction opacity. Our first result is looking better than the rest of it. So let's start with increasing the edge distance to get the seam better. I will use another edge detect node, but this time I will use this edge detect node to offset the outer border of our CRT screen. And then I will blend it with itself with the max lighten option, and also I will invert the color, and this time you can see that we have widened CRT screen. Then we can use the edge detect node to be used on this shape. Now we can increase the edge width to get the overall CRT screen shape to be blended with the inner frame. Now this time we have a better blending with the inner frame. Also, we can adjust the blurriness again, or edge width, to get a better alignment for the screen here. Also, it's possible to get an seam, but I don't like the way it looks because it's not uniformly distributed, because our shape is very disturbed on the sharpness inside. So it's better this way. So you can see the difference here by our texture. This is the bumpy CRT screen. This is the one we are subtracting from it, and this is the result, which is smoother on the edges. And also we have a bumpy screen here. Let's change the curve a little bit because we have a high bump on the center. Which looks better. If we change the curvature a little bit more by also decreasing the overall white value. Control the bumpiness here. This is better. And also we can add a color-wise frame to the CRT screen, because there are also a black band around the CRT screens, which looks good on many screens. Let's tidy up our CRT screen nodes. Right. Now we can use this edge node as an additional black color as a frame for the screen. So we can use a blend node prior to the general blending of the screen by adding a black uniform color. Just add a frame and name it as screen black band. And also for the mask, I will use the one we have created for the screen without the blurring. Even the band exceeds the outer range, it will be cut off by this screen mask. But as you see, it isn't get past to the area where we want this frame to be placed, like the inner side of the inner frame. So I will add another, I will copy this edge detect node and increase the edge width. Then I will use it as a mask on the screen. So let's check the result by increasing the edge detect node, and you see that after increasing it a little more, then you can see the color changes on the CRT screen color. Maybe we have increased the general shape more, but it's better this way. Let's not touch it. So we will just have the black color on the screen edges. Alright. Also, we may want to tweak the height blending of the screen a little bit more. To do that, we may use a levels node and then push the white values for the screen. I think this way it's looking better, but we may adjust the edge the black band like this way. Still, I'm not happy with these corners, by the way. Increasing the black values helps a little bit, but we may use the previous shape to use the edge color to get more effective result on the black band. Let's finally blur it a little bit to get the final touch of this black color. Let's increase the blur a little bit to get better result by here, because it's the height displaced area, so we get results in lower resolution on these areas, because the polygon here is using the UV area much more unbeneficial than the rest of the layout of this shape, because it's projected from the front view, so there are skewness on this area, so the polygon texture is not distributed here as the rest of the model, so the sharpness goes here, goes away, and also we have skewed result. Now we are happy with the CRT screen. We have adjusted our roughness values. Now we are going to create some metallic variation on the general texture. Next we go for the detailing on the normal map. For the metallic values, we will just add a metalness here on the grills, and there is no additional metallic values should be on this texture. So I will just add a simple blend, add two grayscale colors for the metallic values. One is 0 and the other one is a bit higher metallic value. So this one is the general metalness value, and the second one is the speaker grill metalness value. Let's blend these two together. The mask of speaker grills, creating a copy from the actual mask that we have used on the base color before, and then I'm connecting the metalness output of our blending to the metallic channel output. You can see that when I change this value, it affects the metalness of this grill. Since it's black and painted, the metallic effect doesn't recognize so easily, so it doesn't matter so much, because since those are painted with black, it shouldn't be looked as a perfect metallic look on it. So we can move on with the metalness values. But if we need additional metallic variations on the texture, we can go back to this area and adjust our values or add additional blend nodes. For the normal map, we need to add some texture to the plastic parts of the screen. So since they are molded, they should be having some noisiness on their bump values. So let's start with a white noise. First one will be better. And to the final result that goes to the normal node, I will just add a blend node and add this white noise detail to this normal detail with a mask. And for that mask, I will use inner and outer frames together. To combine their masks, I will use the opacity of the inner frame, and then I will take another copy of a mask of the outer frame. I will put their connections to the foreground and background of the blend node and use a max to combine two of them, and use this mask on the white noise blending that goes to our normal channel. You can see that this is very intense effect on the texture, so I will decrease the opacity of this blending. I've changed the wrong opacity. Now you can see the result better if I adjust the opacity level to a lower state. We may also use a very little blur to get a much organic look on this plastic. Also, let's increase the roughness of this outer frame because it doesn't look so good to me. And also we can change the base color of this outer frame. Sorry. Maybe we may have a more metallic value on this outer frame because the blackness of the base color will be much more recognizable by this way. So I will add a blend node, add a uniform color with grayscale, increase the metallic value of this to a high level, and then connect the outer frame mask to it to get a metallic outer frame. You can see that blackness increases when I change the metallic value. And also our mask is not right because it doesn't exceed to the very lower area of this shape. We will work on it later. Before that, I want to get to a more better look for this outer frame. I'm decreasing the roughness value. And this is looking better. Now we have to make a better mask for this outer frame. Since we have used blue ratio grayscale after taking our masks from this part, this blurring exceeded the outer boundaries of this frame, so the one we took doesn't exceed to the exact edges of this frame. So we need to level down all the values of this blurred one, blurred frame to get the perfect mask for this object. You can see that the values that which are hard to see with the naked eye is becomes visible when I push down all the values to the bottom. Also, we need to add this corner shapes of the inner frame's outer boundary. Let's see how we can extract this data from this texture. Yes. Actually, the best way is to blend the one we have pushed all the white values to the bottom with this one, using a max lighten blend option. This way we will be having the whole shape with filled inside. Now we can subtract the shape of this inner frame from this one to get the corners at these hollow points. To do that, we need to have the mask for the inner frame, which is this one, and we will use a blend node to make this mask filled inside with white color, and then we will use this mask subtracted from the one we created earlier. Now we have these areas as masked that we like we have wanted. So I'm using this on the mask texture here, so it will, our roughness will be affected and noise map will be affected by this way. And also I will create a copy of our new outer frame to be used on a opacity channel of our metallic channel. So now we have the whole outer frame is affected by this metallic values. Let's see if we need to have this on any roughness blendings. It looks like there is no need on that. This makes our shape looks better. Now I want to create an outer line for this shape to be better recognizable on using displacement maps. So this way we can create an opacity map to just extract these areas. Best way is to do that, combine all our masks by adding each other to adding them in themselves to get the better mask between them. So we have already combined inner and outer frames here. Let's put them to the background of this blend node. So next I will add the screen to this equation, which is here. All right, we have some hollow points on these areas. So instead of adding the screen, let's use this one as a base color background layer. And also next we add speaker frame to this one. Like this. Also there's a wrong naming here. Because it's not the speaker frame. It's just a speaker shape. Because the frame is the one we have created at this bottom edge, which we are going to be used on our final mask. Let's add a blend. Let's add a levels node to push down all the values of this frame to be used on our screen. But I think the best way is to just combine this one with this one, I suppose. So I will be copying the transformation 2D node that we have used, that we have moved our frame to bottom. Before making this movement, I'm blending this one with this one by subtracting them within each other to get the bottom frame of this edge. Then I make the transformation node. Also we have a blur node which makes the corners on the bottom side like here. And then I will add a levels node to push down the values to all white. This way we have the rounded corners of the speaker shape. So I can add this as a blend in a blend node with the rest of our mask here with a max lighten option. So this time we have the exact outer boundary of our shape. So let's check it by using it as a color on a base color blending. I will invert it to create the outer boundary and define a white color to see if our outer boundary mask works good on our general shape. Okay, you can see that our screen now is extracted from the background. So this way we can use any transparency channel. We can use this mask as in transparency or opacity channels, or use it to extract the general shape from the background of the polygons that we are going to use this on. And this is our screen shape, and we can move on to the rest of the shapes that we are going to create our general monitor, which we will be using on our scene. See you on next chapter.